Hello everyone, my name is Mr. M and today I will walk you through the process of developing distance formula using Pythagorean theorem. And so after today's mini lesson you should be able to say the following. I will be able to use the Pythagorean theorem to find a formula that will give me the distance between any 2 points in the plane. So let's get started. So let's start with the right triangle containing vertices A, B, and C and sides A, B, and C as following. So we do have a right triangle. So let's make sure that that is a right triangle. And this is the vertex A. Therefore, this is going to be the side A that is directly opposite from this point. So same thing with a B. This is going to be side B. And this is going to be side C. So A and B are legs of a right triangle and C is hypotenuse. So C is hypotenuse. So we have hypotenuse and we have legs of the right triangle. So for this video, I'm going to assume that everyone who is watching this already familiar with Pythagorean identity. So we're going to start with actual Pythagorean identity, which is c squared equals to a squared plus b squared. So now the question is, what is the c squared? What is the a squared? What is the b squared? Because here, looking at this image, we don't see c squared, we don't see a squared, we don't see b squared. So what is the c squared? We already determined that c is a hypotenuse. So c squared cannot be hypotenuse. A lot of times people are mistaken and they say that c squared is hypotenuse. However, we know from algebra class that c squared is same as c times c. And there is exponent 1. When we have the same basis, we add exponents, so that becomes c squared. Similar for a squared and b squared. But where this c squared comes from? Okay, so I'm going to try to point this out, explain it, so you'll know it from this point on. So imagine, so this means that c length times width, because this is the area. C squared is area. So if this is the length and this is the width, that means length times width gives me what? Oh, gives me area. But where is this area? So look at this image. If you have this side, see, let's call that length. So there must be some kind of width that I'm going to multiply, and I'm going to get the area here. So it's going to look something like this. So we have square, because this is the c, this is c, so c times c gives me c squared. So we get the area here. So that's why c squared is not hypotenuse. C is the hypotenuse, but c times c, or hypotenuse times itself, gives us this area. Similarly, we do the same. For the a squared and b squared. So let's see how that is going to work out. So we have now a square, slightly smaller square, because b is the shorter side than c. So we have slightly smaller area, blue area. So this is b, and this must be also b, because this is a square. So b times b gives us this area, b squared. Okay. So now if you move on to a square, or side A, and do the same thing, we add rectangle, bam, we get a area again, because a times a gives us a square. So you see, if you actually replace if we actually replace, instead of c squared, a squared, and b squared, these areas or rectangles, we end up with the following. So as you can see, we end up with big area is equal to sum of those two smaller areas that come from the triangle. So once again, c squared equals a squared plus b squared is nothing but sum of two smaller areas is equal to this big area c squared that comes from this right triangle. So now that we have a better understanding of what c squared is, let's move on to developing our distance formula. But before we do that, let's review that Pythagorean theorem allows you to find the missing side of a right triangle if you know the other two sides. In this activity, we'll practice using Pythagorean theorem. So let's see if I actually align this triangle with this line. So now let's actually move it here in the corner so it's not in our way. And let's say again, so this is hypotenuse C. So this is hypotenuse C. This is side B, and this is side or leg A. So we know that c squared is equal to a squared plus b squared. So in order to find the hypotenuse, we first have to solve for c. And then let's see, that should be pretty simple, because now if you take actually the square root on both sides, and I'm going to pick a different color so we can see the difference. So if I take the square root on this side, I'm going to do the square root take on the other side as well. So the square root and the square basically cancel each other out. So we get absolute value of c. I'm using absolute value because distance always must be positive. So that's going to be equal to square root of a square plus b square. Okay. You know, we can just call it, instead of absolute value, we can just say c equals square root of a square plus b square for simplicity. So now that would be our hypotenuse. Okay, there'll be length of this side of the triangle. So for a second, I'm going just to remove this triangle, basically this hypotenuse. I'm going to take it over here. So if you look, so now that's C. That is C. So that is C. So you see, to find the length, so from this point, that's the length from this point to this point. So that's the length or distance. Distance between those 2 points, and let's call that A and B, as we did before. So distance between A and B. So that's how we can find it using this formula. But in order to find the distance of this hypotenuse or this segment, is actually we have to have A and B. So that means we have to have those two sides or legs of the triangle. And because now we're talking about distance, instead of C, I'm just going to call it D. D for distance is equal square root of A square plus B square. But then you're going to say, oh, that's not the distance form I remember. I know it was much more complicated, and I really don't remember right now, but that's not it. And you're right, because if I'm given any points anywhere in a plane, it will be really difficult to just use this formula to find the distance between those 2 points. But let's see how we can actually develop that from here, because at this point we are really close to actually finding the distance formula. So at this point, let 2 points in the coordinate plane be A and B, such that A is x1 and y1 and B is x2 and y1, y2, and we're gonna draw a dashed line from each point to reflect on x and y axis. So let's do that. So I'm just going to pick 2 points, 1 point right here, I'm going to call it A. I'm going to pick a point, for example, right here, and call it B. Okay, so now we see that if you reflect it down on the x-axis, this is going to be x1, and this is going to be x2. Similarly, this is going to be point y1, so y1, sorry for my mistake, and this one is going to be y2, and we're just going to connect those 2 points. So let me pick a segment. So we're gonna just connect that. We're gonna use black color. So now we have this point, or this line, but as you can see, if I actually complete rise over run, if you remember slope from algebra class, so now we get a triangle. So, and we get a right triangle. So now this is the segment, and we're gonna call it D because we want to find the distance of this segment. Okay, so now we see this point A. What is the coordinate of this point A? Oh, x1 and y1. Exactly what we said over here. And then point B is going to be what? Oh, x2 and y2. Since we already developed distance, partial distance form, or if I can say that, so, and we know that D is equal a square plus b square. So now what I'm gonna do, I'm gonna do some substitution here, but I still don't know what A is, what B is. So let's see, because this is the side A and this is the side B. So what is the side A? Okay, let's look. Well, actually, it doesn't matter if this is A or B. In the previous slide, this was B, this was A, but that doesn't really matter. So side A is going to be, oh, initial point is x1 and terminal point is x2. So I can say that A is equal to x2 minus x1. So I take ending or terminal point or ending point minus the initial point. Therefore B is going to be what? Oh, initial point is going to be y1 and terminal point is going to be y2, so b is equal to y2 minus y1. You can also do x1 minus x2 and y1 minus x2. It doesn't matter because you're going to square it and then you're going to end up with a positive number either way. So that's really not a big deal. So d is equal, so now instead of a, I'm going to replace x2 minus x1. So we have x2 minus x1, and we're going to square that, plus this plus. Instead of b, I'm going to plug in y2 minus y1 square. Therefore, this is our final distance formula, and that's probably the one that you remember, that you try to memorize. But now you can see how you can actually develop it in a case you need to, in case you forgot. And then, but if you understand this process, then most likely it will stuck with you for a much longer period of time. Anyways, let's try now use this formula, how it actually works in one simple example. So find distance between 2 points. So it doesn't matter which point is initial, which one is terminal, but I like to pick one. So because this one is A, I'm going to call this initial point. So this one is going to be x1, and this one 5 is going to be y1. Therefore, this is going to be terminal point. So this is going to be x2, and this one is going to be y2. Using the distance formula, square root of x2 minus x1 square plus y2 minus y1 square, and then we just substitute values. Instead of x2, I'm going to use 4 minus x1 is 1, so I'm going to use 1 square plus y2 is 2 minus y1 is 5 square. D equals 3 square plus negative 3 square. So D equals, or distance equals, square root of 9 plus negative 3 squared gives us also 9. So we get that D, or distance, is equal to square root of 18, which is equal to square root of 9 times 2. Therefore, distance is equal 3, because square root of 9 is 3, square root of 2. So in this case, that would be our final solution. So distance between those 2 points is 3 times square root of 2. So if you really like this video, please write comments, give me some suggestions, and if you do have any homework or any other questions, please ask, and I will, in order I will receive, I will do them and post them on YouTube. And so hopefully they could help you out, not just with homework, but also to prepare for exams and any other assessments, or you're just curious how something is done. Please let me know, and I'll do it for you as soon as I can. Thank you.